Hello, welcome back once again. Today we have another interesting quadratic equation. Yes, this equation is very interesting, and here we'll be solving for the values of x, both the real values and the complex values, right? Now let's get started. We have 2 minus x to the power 4 plus 3 minus x to the power 4. This is equal to 7. Now let's start with a substitution. So we're going to let 2 minus x equals a. I'm going to let 3 minus x equals b. Whatever value we get for a and b, we can use any of these equations to solve for the value of x, right? So here we can solve for the value of x in terms of a here, and x will be equal to 2 minus a, right? Okay. Now, since we have 2 minus x to be equal to a and 3 minus x to be equal to b, the original equation would be a to the power of 4 plus b to the power of 4, which is equal to 7. Okay, now, what about subtracting b from a? That is a minus b. This will be equal to 2 minus x minus 3 minus x. So this will be equal to 2 minus x minus 3 plus x, and that is equal to negative 1. So here we have that a minus b is equal to negative 1. Now let's take note of the following. A squared plus b squared, this is equal to a plus b squared minus 2 times a times b. And again, a squared plus b squared, this can be written as a minus b squared, then plus 2 times a times b. Now, from here, a to the power of 4 is same as a squared, then raised to the power of 2, plus b to the power of 4 is same as b squared squared. This is equal to 7. Now, let us first make use of the first identity here. So this will become a squared plus b squared. You know, a squared and b squared will be the base here. Remember, the base here, a and b, we have the sum squared. So we're going to have the sum of the squares of a and b squared, then minus 2 times a squared times b squared. Remember, a to the power of n multiplied by b to the power of n, since they have the same power, is same as a times b all to the power of n. So here that will be a times b squared, right? Then this will be equal to 7. Now, inside this bracket here, let us make use of this second identity here. So that will give us a minus b squared, then plus 2 times a times b. Then remember, we have a square here, then minus 2 into bracket ab squared. Then this is equal to 7. Remember, a minus b is negative 1, so we're going to substitute. So here a minus b squared will be negative 1 squared, which is 1. So we get here 1 plus 2 times a times b squared minus 2 into bracket a b squared. This is equal to 7. So let's make a substitution by letting a b equals m. So we're going to have here m squared, so we're going to have here 1 plus 2m squared, so sorry for that. Then minus 2m squared, because ab is squared there, then this is equal to 7. So from here, expanding this, we get 4m squared plus 4m plus 1, then minus 2m squared, subtracting the 7 and setting everything equal to 0. So 4m squared minus 2m squared is 2m squared plus 4m. 1 minus 7 is negative 6. This is equal to 0. Dividing throughout by 2, we get m squared plus 2m minus 3. This is equal to 0. Writing the equation as m squared plus 3m minus m. Is that 3m minus m? Yes. Then minus 3, this is equal to 0. Here m is common, so we get m plus 3 Negative 1 is common here, we get m plus 3. This is equal to 0. Factorizing, we get m minus 1 into bracket m plus 3. This is equal to 0. If this product is equal to 0, either this is equal to 0 or this is equal to 0. So if m minus 1 is equal to 0, then m is equal to 1. If m plus 3 is equal to 0, then m is equal to negative 3. So right here we have that m is equal to 1 and m is equal to negative 3. Remember, m is equal to a times b, so we get here that the product of a and b is equal to 1 or negative 3. Okay, now we have two cases here. So remember that a minus b is equal to negative 1. So here let us make use of a times b, which is equal to 1. So this is our case 1. And we have our case 2, a minus b is equal to 1 when a times b is equal to negative 3. Okay? Okay, now from here, from this equation 1 here, so from this equation 1, let's solve for a in terms of b. So we get a is equal to negative 1 plus b. The same thing here, that a is equal to negative 1 plus b. So let's substitute the value for a in equation 2. So b times a will be same as b into bracket. Instead of a, we put negative 1 plus b. Then this is equal to 1. And the same thing here, b into bracket negative 1 plus b is equal to negative 3. So here we have b times positive b, here is b squared. B times negative 1 is negative b. Subtracting this one, setting everything 0. Here, b squared minus b, then we add 3 to both sides, right? Because the 3 is negative, this is equal to 0. Now solving for b here, we find out that b is equal to negative b will be 1 plus or minus square root of b squared minus 4ac here will be 5, then divided by 2, and here b will be equal to 1 plus or minus, this will be square root of 1 minus, what am I doing? Oh God, okay. So here will be 1 minus 12, which is negative 11, which is iota square root of 11, then divided by 2, right? Okay, remember that negative 1 plus b is same as b minus 1. So we have that when b is equal to 1 plus root of 5 divided by 2, a will be equal to this minus 1 or minus 1 plus this. If you check it out, that would be negative 1 plus root of 5 over 2. So we have again b is equal to 1 minus root 5 over 2. Then a will be equal to negative 1 minus root of 5 over 2. Okay, so here, let's solve for a. When b is equal to 1 plus I root of 11 over 2, a will be equal to negative 1 plus I root of 11 over 2. When b is equal to 1 minus I root of 11 over 2, a will be equal to negative 1 minus I root of 11 over 2. Okay, now from here, sorry for this. So from here, let us solve for the x values. So we're going to make use of the a values. So remember that x is equal to 2 minus a. So here, let's make use of the a value. So here we have x1, that is the first value of x will be 2 minus a. Let's make use of this value here. So 2 minus into bracket negative 1 plus root of 5 over 2. So this simplifies to 5. Yes. So that simplifies to, this plus and this minus here. So that will be 5 minus root of 5, then divided by 2. So here x2, these are the real solutions. So this will be 2 minus here, negative 1 minus root of 5 divided by 2. That is the second value for a here. So this will give us another real solution. That is 5 plus root of 5 divided by 2. So we have these two real solutions. Now, how about these complex solutions? So let's make use of the complex values for a. So here we have x3 will be equal to 2 minus negative 1 plus I root of 11 over 2. So this will be equal to 5 minus I root of 11 over 2. And finally, we have the last value for a here, which should be the other value for, the value for x, So here, divided by 2, so this will give us 5 plus I root of 11 over 2. So here we have the complex solutions. Thank you for watching. Please kindly subscribe to my channel. Also like, comment, and share. Bye-bye.